In this video, we are going to see in a general way what it means to find a solution to a Markov decision process. Remember that solving a control task consists of maximizing the expected return. The value of a state is precisely that expected return, so solving a task involves maximizing the value of every state, or maximizing the value of every Q value. To maximize those returns, we have to find the optimal policy, which is the policy that takes the optimal actions in all states. On the other hand, the optimal policy is precisely defined as the policy that in each state chooses the action that leads to the maximum expected return. Using the value of the states, we'll take into account the states to which the action leads and the return that we expect to obtain in that successor state. Using the Q values, we'll simply select the action whose Q value is highest. But we seem to have a problem. To find the optimal policy, we have to know the optimal values. And to find the optimal values, we have to know the optimal policy. It seems like we have arrived at the chicken and egg dilemma. How can we find these two elements if one depends on the other? For that, let's revisit the Bellman equations that we saw in the previous video and see what condition must hold when the policy and the value functions are optimal. Let's start with the Bellman optimality equation for the value of the states. The optimal value of a state is the expected return following the optimal policy. The optimal policy will always choose the action that maximizes the expected return. And the expected return is this expression here. The probability of reaching each successor state by taking the optimal action multiplied by the reward achieved by reaching that state, plus the discounted optimal value of that state. In turn, the optimal Q value for an action in a state is the weighted sum of the returns obtained by reaching each of the possible successor states, weighted by the probability of reaching that successor state. The return is the expression you see here, defined as the reward achieved upon reaching the successor state plus the maximum Q value among the actions for that achieved state. In the next section, through these two formulas, we will develop methods capable of finding the optimal policy and values iteratively.